What do we, should we just get the pizza, go raid the beer, get out of here because you're good? Just wait. Here comes the kicker, right? I mentioned the months for those articles, but I didn't tell you the years. Does anyone want to guess when they were each written? And you don't have to guess the year, just guess the decade. If you guessed 1980s, you were correct. The first article, he wasn't Bill Gates then. He was William H. Gates. And he wasn't talking about AI. I did cheat a little bit. It was a computer on every desk, right? The second article, Does Everyone Need to Learn Programming, was from January 1984. Do you know what language, for those who code in the room, do you know what language the author was writing about? By the way, you could see this was from like the style section of the New York Times. This is like, and this is back when print subscriptions were high. So like the average American was reading this article. And this author, this columnist was saying, don't learn to code because it's gotten so easy, you can hire someone to do it. Do you know what language they were talking about? Anyone want to guess? Fortran's a good guess, basic. It was C. C, right? And we're going to write Python, which is written in C. If they don't teach C in college, they used to teach C++ to freshmen, or first years. We've made, that's way too hard. It's way too low level. You have to do memory management in C. It's too hard, right? So we do it in Python now. So like the theme here is there are a number of macro trends going on, but just so you know where I'm coming down on this, we see every day quotes that look just like this one. Like, oh my gosh, this stuff is moving so fast. It's so powerful. It's going to be so amazing. We have been saying this, or the smart people in tech have been saying this for close to 40 years. And by the way, has anyone's needs been solved? I still don't have the robot yet that Paulie had in Rocky 4. Remember that? Right? Like, it's not here. We're going to have to build it. Now, that's wonderful for us if you're like trying to get a job, you want to, et cetera. There's an opportunity to build. And then critically, the second article, the lesson here is that as coding gets easier, which if you've written code and you've seen C versus Python, oh my gosh, Python is so much easier, right? As coding gets easier, as the cost to write software falls, we get more software, not less. So in my opinion, program jobs or people who write programs as software as part of a job, that's not going anywhere. We're going to have way more of that because Gen AI, large language models, are making it so much easier to write code. So we're going to have more and more code. Let me just quickly check the chat here. Okay, great. Thank you, Mehdi. Awesome. All right. So every subject matter expert, and you are a subject matter expert in something, or I'd encourage you to become one, you are now also a developer, a designer, an analyst, or quant, and a builder. That's what the AI will help you do. Will help you develop, design, analyze, build. You still have to know the business problem, the thing you're trying to solve. That's what you need to get real crystal clear on. By the way, going back to the Stanford article from the very beginning, that's the biggest problem. That's the hardest thing to do. Do a quick time. Jeez, I always run long on this. Okay, so here's what we're going to build tonight. We're going to build a mortgage advisor. That's our notional use case. And we're going to explain why we're going to do this as our first agent. And in doing so, we're going to explain what an agent is. And we're actually going to build one. If you have your laptops, I can't make you, but I'm going to type out the base, the heart of this agent. Okay. So we're going to build an agent. Now, people a lot smarter than me, and I'm sorry for smushing the link here, but if you're not following Hugo Brown Anderson's work, he does a great job. And he has put together, he has this graphic I love called the Builder's Playbook, Building Your First Agent, right? So we need to level set a little bit. First of all, this Gen AI thing, what do we mean? What are we talking about? Large language models. So Gemini, the OpenAI models, Anthropic's models, Claude. These are all massive sets of weights that these companies spend a ton of money to train on the open internet that we can now use. If we're going to build an agent, it means we're going to work directly with that large language model, not through ChatGPT or Claude or a visual tool. We're going to work with it directly. Excuse me. And what is an agent? An agent is something that pings or talks to a large language model and then has one or many external tools. Now, I'm not going to talk about steps 3 and 4 because I think Hugo might be overcomplicating this slightly. For the beginner audience, or for those of us in the room, we really need to concentrate on just these first two pieces. If we have a large language model, if we have a tool, and we put this into a loop, we have an agent. That's it, right? That is it. So when people are like, I'm going to build an agent that's going to automate a million different things, what they're telling you is they're going to have a large language model. We're going to use Gemini. And then they're going to have a series of tools that take discrete actions, meaning they are going to do things like send emails, look up records, calculate formulas, which is what we're going to do in this example with the mortgage advisor. I'm going to explain why this is critical now. So here's the agent pattern. Here's sort of high-level architecture. As a user, you're going to ask a question. The large language model, the Gen AI piece, this is the magic part, right? The magic AI model is going to do some thinking. Critically, oh so critically, when you build an agent, is you then are going to give it one-to-many tools to execute. This means what we're going to do is we're going to have this large language model interpret the question, but the large language model is not free to hallucinate or do whatever the heck it wants. We are instructing it, excuse me, based on the questions we ask to only use the tools we provided it for certain answers. We're going to constrain the intelligence of these AI systems. We're going to, in essence, or not crudely, make them dumber. Now, why in the world would we want to do that? Why would we not just want to let the AI model YOLO and give us whatever it wants? Isn't it brilliant? Exactly. What was said was to make it predictable. So our challenge right now, and by ours, I mean like the world's challenge, why AI projects are failing, why Jeremy Grantham thinks this is all going to be a bust, is that we are trying to use a tool that is inherently non-deterministic, meaning you don't know what answer you're going to get, right? This isn't like Forrest Gump box of chocolates. You don't know. And if these models make something up in an important context, like for your job in a business context, you then can't really use them. You can only use them in processes where you're already screwing up all of the time, which may feel like most of us at work, but for the if I'm calculating a mortgage rate, I don't want the model to make up the formula for amortization. There is maybe simple. It's not simple for me, but there is a standard formula for that, and I want the model to use that formula. When the model is going to look up products in my database, I want it to look at the database, not make stuff up. I want it to run specific queries that I've already programmed. I want it to have information about the products from my customers that I've explicitly set, that we as the humans, as the business people, have decided this is the truth. Use this, do it this way, so that every single time I get back the same answer. Now, that doesn't mean we're not using the LLM or there won't be any aspect of whether we call it non-determinism or just potential hallucination, stuff getting made up. We want the LLMs to help us answer questions, because this part is really hard, right? Interpreting user questions, natural language, what people say, what I'm saying right now, making sense of it, very difficult. LLMs, fantastic at that. But once it's done that, we want to constrain exactly what steps it takes after that. So let's look at this in practice here. Step through what we're going to do. So why would we use tools in this example? We're going to build a mortgage rate advisor. We're going to ask questions like, we're going to all be lenders, and our potential customers are going to come to us and ask for a loan, compare different loans. My credit score is X, I'm 15-year, 30-year, et cetera. We have specific data. Let me not say we don't. Large language models were trained on the internet, meaning they went through the people who created these, like Sam Altman and company, and they pulled down everything from Reddit, all the internet pornography, all of that, right, is what they trained these models on. And then at some point when they released them, that means the training stopped. So if we ask a question of one of these large language models, like what happened today, it doesn't know, right? Because it wasn't trained on that. The training it took place to a certain period of time, training stopped, we're now here. So at a minimum, we need tools that are going to help us go get current information. And then again, critically, if we're in a business context, we want to use our company's data. And we're going to want to use that and say, don't make something else up. Don't look elsewhere. Go here to get this data because I trust that we're governing it. We know this is what we want to use. Second, that's I think is we're seeing this a lot is with math. So if you ask a large language model to calculate an equation for you, it will go out and do it. What we want to do is say, no, there's one way in our business that we calculate churn. There's one way that we do LTV. There's one way that we do amortization, et cetera. You need to lock this stuff down. Otherwise, you'll get different answers. And if you don't have that, any sort of regulatory or compliance issue, which in the United States, at the moment with this administration, we don't really have much going on, but that's very likely to change in the long term. And Europe, by the way, is pushing hard on regulation and compliance. So what the bankers and the insurance companies go through now with regulations like SR 11.7, where they have to document all their models and they have to provide reason codes if they want to deny us credit and all this sort of stuff, we're likely to see more and more of this everywhere as AI gets used. So that's why we want to use tools. That's why we need to build agents, because the LLM, the AI model alone can't do this unless we constrain it. Okay, so that was plenty of talking. Let's get started. So I'm going to, if you have your laptops, great. I'm gonna have to put this mic down. I'm gonna open up here. I've created a Google, well, first, I guess, let me close this out. And I'm going to grab this link. And if I'm doing this correctly, I should be able to. I'm pasting the Replit link here. And if you're following along, we're going to remix this app. I'm going to call this one. And if you get a little stuck here, that's okay. Right? We can work through this. And the first examples, you won't need an API key to paste in. I'm realizing now if I share my screen, there's no way I can hide my API key. If I'm actually going to paste it in. So I don't know if I want to stress test the budgeting I set on Gemini. That may be the one piece of this. But so here's what you have is when you click this link and open up the Replit environment, you have everything that we're going to build in this tutorial. So you have what you're looking at right now is a Streamlit application. It's just a web app written in Python. And this behind the scenes is our agent, and that agent has two tools. It will look up rates from a database, which is just a CSV in this example, and then it will calculate mortgage payments. So we can ask questions like, what's the rate? And let me jump over here actually where I've already set this up. What's the rate for a 30-year mortgage for somebody with good credit? And it's going to return the response for us from this database, 6.625. We can get a little more complicated. So like, what are my VA loan options? I can help you with that. This is where the AI is helpful. I want a 15-year loan, and let's say I have fair credit, and I want to borrow, because our housing market is insane, $800,000. Something like that, right? Oh, it can't do fair credit. Okay, fine. Let's do 30-year good, 800. Okay, so we're getting some interaction, and then we're running deterministic formulas. Now, how do we build this? How does it all work? What you're going to do when you open this up, we're going to go under the hood here to the shell. And so let me clear this. And I apologize if this is a little small for those of you in the room. We're going to try to zoom in. So welcome to the command line. This is just like in the Matrix, which is now like a zillion years old. This is how we interact with, or a way of interacting with files. Some of those files can be code. I typed ls, that's for list directory, so it's going to show me all the files in this directory. Again, if you open this link, this is exactly what you will see. You won't have to change anything. There's nothing for you to load. It's all just right here. And the code that we're running is this file here, this app.py. There's a decent amount of code in this, so we're not going to start here. We're going to start with something a little bit simpler. And what we're going to start with is our base agent. You guys, yeah, go ahead. Yes, 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 yes. And someone was nice enough to put it into the chat. So if you were able to access the Zoom chat, thank you, Manny, for doing that, and for others. And I can also put it, it's back up here. And I've also put it on the Meetup. If you go to the Meetup comments, there's a Meetup comment. Oh, I can't. Okay. Awesome. All right. So who's ready to build their first agent? Yeah, go ahead.
How did you get to the workspace?
The workspace?
Yeah.
Oh, good question. So if you click this little plus button, you can search, or it may just be right here, shell. Shell. Yeah. Now, so in this case, you're right. I should have shown you that. We went to the shell. So let's open up. I'm going to open up using a command line text editor. So think like Microsoft Word, but for nerds. We're going to do this thing called, or I'm going to open this base agent tutorial. So let's open this up. Okay. Now I've put some code in here already. It's our job to actually implement the agent. So what you're looking at, and if you don't mind, I'll zoom out just one level so we can see the whole thing. Okay. So we're going to implement our first agent here. And if this looks boring or like, this is some code, it's gross. Like we're getting to the Streamlit app, right? Like this is the heart of that Streamlit app, of that web app. We have some imports. Critically, I have this package installed called google.genai. Anyone want to guess what Google? And so you can see here, if you just read this like in English, genai.client, that's like us going through our browser, but we're doing it from the command line. And I'm passing in an API key. And I'm going to zoom in on this just for a second. So this part is a little bit wonky, this os.getEnd, like what's going on here? If you're at home, you could just paste in your API key, which consider it like a password. You could just paste it in. It's not a good practice. Just like a password, you want to use a password manager you want to protect. So what this setup is showing is that there's an environment variable called Gemini API key. And that is essentially the key with a secret behind it, which is my password. And you can see those. Hopefully I don't share the actual password, but you can see those here. So there's a secrets manager within Replit. And if you wanted to add a different secret, which I apologize, it's always hard when you're kind of zoomed in, but you can type the key name and then paste in the password. Just be very careful with these, or I'm sorry, be very careful. It's like, you never say that to your kids. Like, well, what is it? What are you actually telling them to do? Always use secrets if you're going to be sharing any of your code. Do not paste API keys in plain text, especially now, because if you end up swiping your credit card for one of these things and not setting a limit, someone could grab it. They could run up a big bill. So I'm not saying be careful. My recommendation is to always use secret keys. Do not paste these in plain text. Okay. So with that out of the way, let's go back to our code. So, I'm sorry. Okay. This next line here is also not super important, but in lieu of having a web app that we can type into, we're going to pass an argument via the command line. That's all that this does. We don't really have to. Okay, fine. Oh, and then anyone want to guess at the end is print response.text, what this is going to do? Yes, it's going to print the answer. So our job here in the middle is to implement this agent. So we're going to do this right now. And because there isn't that much code, I'm going to do my best to actually just type it as we go. So I need to print the response. So response, and I'm going to say client.models.generate. By the way, again, you already have all of this code and it's in the GitHub repo too, but in the spirit of like, if you write something out 5 times on the blackboard, it may feel like super old, but it's going to help you learn. Like it really will, these sort of things, they help me learn. So we're going to run generate. I'm going to tab complete should have worked. Models.generate content. And then the model we're going to use is Gemini. You could change this, but I'm going to use Gemini 2.5 Flash because so far it's been pretty cheap. In all my testing for this, I think I've spent like 15 cents. And again, you should be able to use a free API key, so that shouldn't be a problem. Okay, and then contents.query, and then I'm going to close out my graph. All right. So if I've done this correctly, and I'm going to close this now, I'm going to use :X is how you close in Vim. If you haven't used Vim, don't worry about it. We'll get. And I'm going to run now Python base agent. So this is going to let me just talk to the large language model, and I'm going to say, what is nice about Chicago? We're going to see if this works. Doing it live. I don't know if it will. Okay, come on, Gemini. Come on, Gemini. And the script, by the way, again, oh, look, this got all this craziness text. Okay, lots of nice things about Chicago, right? Wonderful. But just to show you how, I mean, again, the weaknesses of this approach, let's change our question to what is happening with, what are they called? Teen takeovers. Are these a problem in Chicago? In Hyde Park. And we actually may get an answer here. I was testing this earlier with a slightly different question. But the key thing is we want the recent information. We want like what the mayor said about this today, right? Is what I would like to know myself. Oh, I see. Actually, we do get some answer here, but it's general. Key incidents. Look, summer 20. This is even better than I thought. Summer incidents from 2023, right? And I'm going to be a little unfair here, but not really. This is the huge problem with using unconstrained AI. This is why we want agents. We need to add tools. Otherwise, we get stuff like, of course, I'm not asking about 2023. Now, in fairness, could my question have been better? Yeah, absolutely. But if I'm asking about a domestic disturbance or like a local issue, I mean, recently, like 3 years ago, like I mean, if I'm doing a book report, sure, but right, the model was trained on all this historical data, so it's pulling from where it has more data, not from what's most recent. And this is using Gemini 2.5. Is it the latest? No, but like it's still very good. And a basic thing like this, the model's going to get wrong, right? So again, if you put this in a business context, we don't want non-determinism. We don't want hallucinations. We don't want making stuff up. We want to constrain. Give it specific examples. So what should we tell this model to do? Naturally, what tool should we add to make our first agent here so that we can get recent information? Yes, we should add search. And the good news is that's very easy to do with Gemini and with the Google AI package because they're all about search. That's what they do. So I'm going to zoom back in. There's another tutorial sheet here. So this is our second kind of like final, like hands-on. We got to go through this. And let's open up this base agent tutorial. You'll notice that this code is all exactly the same. The same imports. We're loading our environment variables. We're passing in our API key. I've copied down the pieces that we had before. So this was our base agent. And let's step through this for a second. So we can go back over it if you're typing here from home or line. Client, models, generate content. So it's going, that's essentially the boilerplate code, but this is saying, hey, I want you to talk to Gemini. Which Gemini model? 2.5 Flash. What do I want you to pass in? What's my prompt? Here, this variable, query, right? The query is what's going in. And what we need to do is implement the search tools. And I'm sorry, I skipped this one piece, but this is where are we getting the question? How do we ask a question? We're going to get it from the command line. So after I run the script, I'm going to pass in some text. That is what the model is going to answer. That's the question we're going to ask. So this is our core. This is your ChatGPT. This is your Claude Anthropic. This is using the GUI for Gemini. This is it, right? The command line version. Now we're going to add some stuff. What are we going to add? We want to add a tool that does Google search. And as we go through in the loan example, we'll add other tools. But the very first tool we're going to add is for Google search. So let's do that now. And it gets a little more wordy. So now I'm going to add in config equals types dot generate content config. And we're going to add in an argument called tools. Types dot tool. Oh my gosh, you're going to be blown away when you see what this tool is called. Google search. Types dot Google search. And now this is also critical. We've given it a tool. What else do we need to give a large language model? Prompt or instructions, how to use it. How do we want you to use this tool? So let's go system instruction equals, and in my case, I'm going to say always use Google search to answer. Oh, did I spell answer wrong? Probably did. Do not rely on training data. And then we should be able to close this out. Okay. If I wrote this correctly and didn't miss anything, we can now run our example. And we're going to pass in with team takeovers in 5. All right, hopefully I didn't fat finger something. If I did, we'll get an error, we'll get to debug it, and that will always be fun too. Calling the model. Okay, here we go. So we got something. I think Mayor Johnson, that is the current mayor, right?
Yeah.
Oh, good. Okay, so we're at least getting closer. April 16th, 2016. Excellent. Now, this is a little bit, it's like both big and small. There was an issue, warning about teen takeovers, recent events include. Excellent. Okay, so we're getting the answer that we want here. Now let's just go back and open that code up. So I want to explain a little bit about what's going on. And I'm sorry that this is a little bit broken on the monitor, but this is a critical piece. So there are two things here. The config, the types, generate content. Don't worry about that. Like you can go ask OpenAI, you can ask Claude. They'll give you you can look at the Google Gemini docs. You can get this piece. The concepts, the conceptual piece here, again, what is an agent? An agent is an LLM. There's our LLM, Gemini. We're calling it via this client, right? There's our LLM. We have to add in tools. What's the tool that we added in? Google search. We gave it a name, Google_search. And this happens to be built in. This is a nice thing. It's built into the Gemini package. So we don't have to even write any code to do Google search. Go figure, of course, Google, that's one of the things they'd make available. That's why I picked it for this example. That's the tool. The tool without instructions, it's not useless, but it's not very good. We need to tell the model how to use the tool. And so we do that with these system instructions. Always use Google_search. This is text that is directly back to this. So if we put something else in here, like always use Bing search, it's not going to have a Bing search tool. It's not going to be able to execute that instruction. So this is the critical piece. We're explaining what's going on in the system instructions. Does anyone want to take a guess? If we were to define these tools ourselves as Python functions, where the system instructions would be within the function? So if I realize I'm now, to answer this question, you kind of have to know what a Python function looks like. But where might text like this show up in a Python function? Or anyone who writes code? Exactly. In the doc strings, which is like helpful, potentially optional, sort of optional text that a developer or programmer can write when they're writing code. And you might, traditionally, people might have skipped it. And that's what the LLMs are looking for. So when you're like, oh my gosh, I need, and by the way, this is where like there's a million concerns that can come from this, but basically now this part of your code, the text, the doc string is as important, or if not more so, than what the rest of the code actually is. This is a big, big deal because now we need to version and govern essentially what are comments in code. So when which is a little bit wild, but like the idea being that you are likely going to have, or at least need to think about the standard way that your company or your team or your group is going to write instructions. And by the way, if you're implementing this, where are they going to go? They're going to go in the doc strings of a function, Python function, which is all the more reason why you want to start writing code. You want to start doing this if you're not already. Because this is, by the way, so basically, what am I really saying? The way that we prompt a model today, you may have a series of files that you upload when you're using OpenAI or Claude as like, here's background, additional system instructions. If you're building agents, you're doing it via doc strings. So you want to be at this level, at least for now. Okay. So thank you for bearing with me through the kind of this text part. Let's go back. Yes, please.
Gemini 2.5 instead of Gemini 3, just so like save on money.
Yeah, precisely.
Oh, okay.
Yeah, just because these are easy, and gosh, I'm not using the free trial, so like sometimes with Google, it's been very inexpensive. But on some other services, I've like not run up big bills, but I spent like $100 on AWS, and it was before I even knew what I was doing. So yeah, I just get nervous. But yeah, and in this case, nothing we're doing is that complicated, so we don't need the cutting edge. Yeah. But that's also, by the way, another, like, just as a quick sidebar, we had some questions like, well, the company I work for, like one of the things that our software provides is a way to quickly change those models and like look at your performance and look at your cost, because this sort of iteration is hard. Yeah. Yeah.
Response due to like which part? Because when I do a Google search on my web browser,
Yeah.
things come back really fast, right? These days.
It's a good question. So I'm not sure where the latency is coming from on this. Oh yeah. In terms of I see what you mean in the actual text itself. Yes, good point. And we could ask, by the way, Replit even has in here an AI editor, so I should have thrown the question in. Let's jump over, or we'll go back to other questions, by the way. Yeah.
That system instruction, that's not like a Python code. That's just a text string that you're passing to Gemini and trusting that it's going to do with there.
Yes.
Okay.
Yes. Yeah. Which is kind of wild, right?
Yeah.
I mean, and this is where again, I'm blown, and I'm still trying to wrap my head around it too. But basically, we have to constrain how these models work. They're large language models. We pass in text. We give it we do this, then do that, answer this. And so we need to be very precise and very clear about what they're allowed to do and when. And so if we for example, in these cases, we're saying you must follow this. Now, there should be auditing and guardrails. Again, that's a good plug for like enterprise software companies. But for you and me, it's like, yeah, we just got to go in there and set the instruction, just like we prompt the model. And we will turn streaming on in the actual Streamlit app. Stream part just getting overloaded. But great. Oh, so we built the agent. Sorry, I had some slides here, but we just went ahead and did it. No, we covered all this. Okay, great. All right, wonderful. Okay, so let's take a look at the tools. Oh, the tools. There we go. The tools. So we're going to implement two tools here, and I'm not going to type these out. So I'm not going to drag you through that, right? But we're going to implement two tools in our loan calculator. The first one is going to get rates, get mortgage rates. Now we're going to pull these. These are just on a CSV file that's in the Replit environment, a basic table, nothing crazy there. We have different types of loans. Matt, you're the banker. This is what your company is currently offering. It's your product sheet. This is what you have. So we have a function here called get rate, and it's going to look up the current interest rate from that CSV or from that table. If you're moving beyond this, you'd maybe replace this with like a database, some API calls, a million things you could do. But this is just reading from a single source of truth. That's the concept. That's the idea here. I don't want the model making up what my company sells. No. I have that information. Use only this. So that's tool one. And the rate sheet, by the way, it looks like this. We've got loans, conventional, FHA, jumbo, terms, credit tiers, the actual loan interest rates, and the max LTV. And we're going to use now, in order to calculate a mortgage, the mortgage payments or the amortization schedule, there's a formula for this. And while it looks a little bit ugly, laid out like this. In the Python code, I think it's actually a little bit cleaner, right? But here we now have our second piece is to calculate the rate. And again, the idea here is not that there's something amazing about this. The idea here is that this is a known formula. We do not want the large language model. We don't want to have any risk that it decides there's some other way of calculating the monthly payment for a mortgage. We want to lock this down. So we'll say, look, at our bank, this is how we do it. And the formula is here. We have the monthly rate. We divide, so basically, hey, the rate is 6.4, divide by 100, and then we need it, the monthly. Then, so the term years is like, if it's a 30-year loan times 12 is 360. We calculate the payments with this formula. And here's the idea again, is that we're all going to use this formula. And if we let the LLM make this up, we risk it hallucinating. And maybe now the models are good enough where it's not going to hallucinate a mortgage payment calculator. But even like 6 months ago, a year ago, we could mess up basic math. And you see these examples all the time. Which, again, why I'm picking kind of a basic math example here. But the key, and I want to like keep stressing this, is as you apply this or think about this in the context of things you might do at your job or a job you're applying for, think about whether it's data that they have or replace this equation with a process. Look for this information and do it this way, because that's the way we do it here. I don't want the large language model making it up. I want the large language model able to interpret what the users are saying and then route appropriately to a specific process, right? So almost like having a greeter at the front of the store, but if I send you over to lighting or to bathroom, like you're going, those are the places you go. I'm not going to send you to McDonald's, or I'm not going to send you to H&R Block. It's like, no, you're in a hardware store, you're going to one of these spots, or we'll have to let you go outside. So that's the big thing here with these two tools. And then as we were talking about, the doc strings become really important. And by the way, what is a doc string? Like these are what go into the data that's under the tool itself, the text. So this tells the LLM what to do. And this is prompt engineering. If that is going to stay a thing, like this is the better our doc strings, that's the better our prompts, the better our results are going to be, which is to me, it's still pretty crazy. It's pretty mind-boggling, but it's like, this is the level of control you want to have. That's where you explain it. Okay. So this is how our tool works, our agent works. So we asked, hey, what would my monthly payment be for this much, on this type of loan, this term, with this credit score? The LLM will still do reasoning, right? In our example, it's not like we don't, but again, the LLM will get the question and it's going to start parsing this and figuring out what we're asking. It's okay, great. I need to get the rate for this type of loan and this type of borrower. We gave it a formula for getting the rate. We gave it a table for getting the rate. The table is this. So it's like, hey, conventional, 275, good credit. What rate am I going to pull? It's going to find the rate here in this table. It's going to do that lookup, just a basic filtering on the type of loan, the term years, the credit. It's going to do that every single time. Okay, hurry this up. Then it gets us back our rate. Keep an eye. Okay. Tool returns the rate. Now, we can calculate the monthly payment. Loan amount is that times that rate at the term 30 years. And we're going to call our function and get back the actual payment. These are the two tool calls so that every time we ask this large language model, what would my monthly payment be for this amount of this type of loan, that term for good credit? We get the rate, and then we get the monthly payment every time. Again, applied to your kind of use case and example. So with that in place, we want to put an application around this, a UI, and that's where we, in this example or in this workshop in the Replit environment, you have the Streamlit app. Which here, let me just show it again so everyone can, so we can see it, and which is in preview. Here's our loan advisor agent, the chatbot. We went from this, or we went from, oops, sorry. That's not what I meant to show. We went from the shell to this. There's a little bit more code involved, which we'll step through in just a second, but not that much more. This is just the wrapper, the veneer, the place, the web app that makes this prettier. And I'll go back to. So what we have here is now we have the UI. This is the chat interface. It does a little bit of a few other things, but as implemented right now, think of it as just like this is the UI. This is the driver's seat. The engine is using Google Gen AI. We have the client. We're going to create this chat. We're going to send it a message. We're going to use our tools. We get back a response. What are the tools? Get the rate, calculate the payment, look up the data here. And like we did some filtering. I'll show you this code in a second, but it's nothing crazy. These are the core pieces. Like I want to build my first agent. You only need, as we did in the beginning, this and this. The Streamlit app just makes it look a little prettier, mostly because when I used to do this tutorial with only the two boxes, people were like, when do we build the agent? And I'm like, oh, because they didn't see a chatbot. I'm like, okay, chatbot. All right. And this was, again, the key code that we implemented together. So just kind of reviewing this. So we're creating the client. We called this model, ping an LLM. That's step one. Add your tools, get rate, calculate monthly payment. This is what we did before in that Python example where we added in Google search. Now we're just adding in the rate and the payment. These are the two pieces. We take this. It's the same thing we did before. Ping the LLM, call your tools. And then we actually did this with a few demos. So, before we go where to go from here, let's switch back and just take a look at some of the code quickly. Yeah, I'm going to show you. Great question. So let's take a look. All righty. Yeah. So Chang asked a great question. Hey, where are the system instructions for this app? It is. So we have at the top some fairly in-depth system instructions. You are a helpful loan advisor. Always use the get rate tool to look up interest rates. Never guess. Always use the calculate monthly payment tool to compute payments. Never do the math yourself. If they ask for a monthly payment, look up the rate, then pass that rate. So this is the part that's like, geez, I have these AI models that are so powerful, but we still have to spell out a lot of stuff for them, right? This is the deterministic process we're putting in place. When I want you to do this, then do this, then do this, which feels a lot like procedural programming to a certain extent, right? This is where it's like, is coding going away? No, like you just, oh, what did I do? You need more of it. Oh, did this refresh on me? We'll jump back in. I'm not sure where my screen is. Okay. Open up. Now this latency I don't think is due. Like I don't know why that was hanging. Oh, it already exists. I have it open in another shell. All right, 1 second. Yeah. Could you help me with that? I would love.
Oh no, it's fine. I mean, you can edit your use a dot app like Peter because you edited at the lost connection.
Oh, so I need to delete this app dot this one.
Yeah. Yeah.
Delete that one. Is that?
Yeah, you can, and then you open that. You don't have it.
Thank you. It's funny. I trust you so much more. If I'd asked like the AI that, I'd have been like, I don't know. Like, yeah, I always get nervous things up. Thank you. I had to learn something there. Okay. So we have our system instructions. Now we have our tools. And by the way, so let's start with the first tool. Just quickly. I know we're coming up on time. I'm let you get out of here, but this is our get rate tool. And you can ask your favorite large language model to help you write these tools, right? Like you don't need to, you're not going to sit here and grind this code out yourself. But what we have here is the doc string, look up the current interest rate from the institution's rate sheet. That's a CSV file. It gives the arguments. And I did use pandas here. This is probably unnecessary for a CSV file, but PyData Meetup figured like people might be somewhat familiar with pandas. So we're reading in the CSV, and then we're just doing some filtering based on what the user is giving us, right? We know we have the term, we need to look up the rate. So nothing crazy here, nothing, there's no LLM in any of this. It's just reading a CSV file and using pandas to filter. And then we have our calculator. Yeah, quick question. So that's this code that we're just going through. So this is this stuff. Yeah, so this pandas code is doing the filtering. And pandas is just a Python library for working with spreadsheet or working with tabular data. So it's very good at that sort of, or it's designed for that sort of thing. And then we have a formula here for calculating our loan payments. And you can see again, the doc string explains what's going on here. So the model knows. And we just have that math that we saw in the slides. The rate divided by 100 divided by 12 times 12, et cetera. Like we just have the math. It's just coded in. Now, should this be in a library? Should be referenced like, yeah, sure. Or yes, of course, excuse me. But for this example, it's like, hey, we look up the data. Tool 1, look up the data. Tool 2, run this equation. Do it this way. Now we can go down to our actual model. And when we create our chat session here, we're passing in explicitly these tools. So it's getting our get rate and calculate monthly payment. And when it responds with that, we'll then we'll use those when it's sent to give us our answer. Now behind this, of course, is like, well, how do we get the web app? Well, here's your Streamlit UI. So this is there for your kind of fun and exploration. But again, this is something that the generative AI models can build for us, right? They can build apps. We just need the structure. I'm going to have an agent with these tools. These are the deterministic things it's going to do. Help me build a UI around it, like with Streamlit. And it gives us this is all the code that the rest of this is basically all the wrapping, the web application.
Did you vibe code this or did you write it?
Oh, of course I vibe coded it. Yeah. The parts I changed were the ones that made it worse, like adding in pandas. So it was like, but for the Streamlit app, of course, because I don't have to be a designer anymore, right? This is the thing, like it's amazing. Now, yeah.
Where's the streaming feature that?
So that's a good question. I think, and the answer would be this.
You get to see a video live, you see the text live, like it's open.
Yeah. So essentially the way that when we were doing this with the Python script, it was waiting until the entire message was returned before putting it into the chat. And when we, if we're using ChatGPT or something else, we type something, it'll be like thinking, assessing, it's returning feedback without the full answer. And that the Streamlit application is handling that or is providing that information. But it wasn't being done in my super basic column. Yeah, thank you for pointing that out. I should add that to the next version. It's going to be like, we're going to make that tutorial 3. I'll have to shout you out for that one. But so here, again, we have this. And so just a couple of quick things. If you choose to use the Replit environment, you don't have to. But the way that this is set up, and I'm sorry, I'm going to zoom out. It's maybe slightly harder to see, but otherwise I have trouble navigating. If we have a second, so the thing I want to show you, this is specific to this tool called Replit. I don't work for these guys. I'm only using the free version, so I don't think they're making any money off of me. But what they do that is so nice that we're using here in this example is when you open this up, your Streamlit application will already be running, will already be going, because there's a shell command that we're able to add. So every time you start this environment, it's going to kick off the app. It's going to run it.
You just mentioned it's a free version of Replit.
Or I have a free account.
Allowed to pay.
Yeah, I think in this case, so you can see I'm in incognito mode here on like another free account. So you could do 10 apps per account. And so I built it in my like normal one. And then to test to be like you all, I created an incognito, a separate one with different email address. So
Subscription one.
I don't know. I haven't paid for it yet. So yeah, I'm not sure. Hopefully they stay in business. There are other tools that let you run code. It's just that I've stumbled on this one because it's easier to provision the environment. So if you go home, you fork that replit, you'll have not only will you have all the code, the environment variables, everything is set. The only thing you need to add is you don't have to learn even how to start the application. It will do that. The only thing you'll have to add is the secret key. So you'll have to come in here and add your Google API key. And when you do, the one piece of this, you can ask their AI assistant over here and it will help you. It has this kind of annoying AI assistant, but
You have to save your result for each project, or just leave it.
these things, it's crazy. They auto save. So essentially that link has, when I give you that link, that's the last version or a part of the project where I said, I'm going to share this. So when you open it up, everything you do in here will persist and it will save, which is also why please don't paste your API keys in plain text anywhere. Even though this can still be private for you when you're doing it, they're persisting everything that you put in there. So like use the secrets is a part of the theme.
Do they allow you to implement NCP in?
I think you could. I mean, I think so. Yeah, they want to be like this. I don't know as much about their company, but they're trying to be this sort of general purpose development and deployment tool for all the applications. Yeah. So the last thing I'll say is when you change that secret key, you can come here to workflows and you can you'll need to stop the application and start it again. And that's how so that Python can pick up the environment variable like you just said. If you get confused on that and it doesn't work, just copy the error you're seeing and put it into Replit, and it will figure in the Replit AI, and it'll tell you what to do. And in fact, it'll even do it for you. But it's just, and this I like this more than trying to find the Python process, kill it, and then start the stream app again. Okay, last thing is that there are a couple of places or things you'd probably want to do from here that you can vibe code. And so let's just, a couple of them would be like adding a debt to income ratio. If you like this example, you could replace the CSV with a database query. You'd have to set up a database. You could add session memory so that it persists over time. So like it remembers who you are. And the reason I mentioned this one, and deploy on Replit. Yeah, you could do that. You could share it with the world, sort of like I didn't show the deploy feature in Replit. You could open up the actual app, not the coding environment, but just the app. But the session memory one, if you're just building, I think is the most useful, because when do you decide? You may have heard about, for those of you who built some or thought about building agents, should I use a framework? There are a lot of good frameworks, and Google has one in particular. They've open sourced Google ADK, Agent Development Kit. I was going to use that in this talk, and in fact, my README still reflects that we were going to use the ADK version of this, but I think it's just a little too complicated for 1 hour. But like the threshold, one good threshold in my mind is like, when should I go with the framework? Well, I want to manage things like I want to remember what a user did like from 2 weeks ago. These frameworks make that much easier, meaning you don't have to write as much or vibe code as much code to implement your agent. The framework will help you with that. So looking at Google ADK is a big, I think the next logical step in my mind as you're playing with this. So start with the basics, you get a sense, ping an LLM, use your tools. And then from there, you may want to expand and say, okay, if I'm actually going to build something for real, a framework might be helpful. And this is all, again, if you don't want the Replit environment, all this code is up here on GitHub. And I pasted those links here in the chat. So you should have access to them. Awesome. Well, I think I might be finally done. Yeah. Thank you so much. It's weird. And yeah, and thank you. I think you get into the PyData community. I really appreciate it. Very nice. Wonderful to get a chance to come out. Yeah. Connect with me on LinkedIn if you want to. That's probably the easiest way to get a hold of me if you want to And yeah, safe travels. Yeah.
Did you have any, or would you be willing to share your experiences by coding, whether Gemini or maybe Copilot in GitHub?
You know, yeah. So one, what I think the short for me as somebody who is certainly not a software developer by trade or anything like that, like English major. I mean, I think it's pretty amazing. That said, is it foolproof? Like, no. So in the past, when I used Python professionally, I was working from a command line interface. I was working with pandas, a little bit of NumPy, maybe some scikit-learn, like the PyData stack. But if somebody said to me, like, I need an insight, I would have handed them like either a REST API or some data. If you wanted a UI, I literally had no idea, right? Like, whereas building stream like these various applications now, I ask it, I know enough to be dangerous, but yeah, I think in that sense, it's amazing. Where it can get really annoying when you're using technology, like especially some of these other tools, like I'm trying to preparing for this talk and preparing for others, I'll run into an error I can't fix or I'm confused about. And then I'll ask Codex or I'll ask Claude Code, help me fix this. And it will give me a very plausible but totally incorrect answer. And if I'm not careful, we can run down a rabbit hole for an hour where it keeps suggesting fixes, but we missed the problem. And I can even give you an example of that. So I'll try to keep this short. From this talk where I had, and I'm trying to think, was it the error in the Gemini model? So I was originally doing this, I was going to have a RAG component to this, a retrieval augmented generation. We're going to upload unstructured documents. With the loan example, we cut it down just to keep it, I thought it a little bit much. But in doing that, Google has changed their latest text embedding model. So like there's a model we use, Gemini 2.5 Flash. There are other models you use to turn text into numbers so the large language model can read it, right? Details don't matter. But there's a specific thing I got to type in, name for that model. They recently updated it, as in like they updated it a month ago. So when I was asking Claude for help with this, it was referencing the old name on the old API. And it didn't realize that simply the name had changed. It wasn't looking that up. And so we just kept coming with new, oh, it must be this, it must be this, it must be this. And I'm so embarrassed, but like after about an hour, it's like my kids are like, why aren't you done with work? And I'm like, oh, I'm not really working. Like, like what's going on here? It was, I'm on the wrong, on the V1 API, on the, whatever they call it, their beta API, the standard that Google uses. Just needed to change the name. And if I just would have looked it up, like what is the name of the text embedding model, I would have found the right answer. Sorry, so that was a long answer to your question, but like, yes, massively more productive, but also you can end up doing, I've done some really dumb things. Okay. And for some of the questions in the chat, like the slides that I posted to the meetup, comments, or at least they should be, if they're not, I will add all of that to the meetup comments afterwards. And it's in the GitHub repo. I'll make sure it's updated. Yeah.
You do a lot of pipe coding, but my question is about planning. So how do you plan it? What can help to plan better?
I mean, I think this is our biggest challenge. I have no silver bullet here. And as we spend all our time at work now, I feel like when I'm working with customers, just enterprise companies who are trying to implement AI projects, what are we actually trying to solve? And that's always been the hardest problem with technology, but it's even more so now because it's so quick to be like, well, let's just build something. Let's build something. Like, well, where are we going and how will we know when we got there? And that hasn't gotten easier. That Stanford paper, by the way, has a ton of great anecdotes on just this. So it's all the more reason, I think, for all of us to lean into the technical stuff, but really to be subject matter experts, be people who understand the problem, students of the problem versus like, I'm somebody who's really good at at develop. It's like, well, we should be better at whatever it is, the thing that we're trying to fix. I don't know if you guys, yeah. Want me in the back to me? Yeah. Yeah, there is. And I stopped sharing my screen. But there's a bunch of ways to run to run different models on your local machine or on a big GPU server if you have it. One that I use locally is called Ollama. Ollama is fantastic. And so like Google opened up recently a model, I think Gemma something, and it's amazing. And you can run it on a standard laptop. You'll probably want, I mean, for like stuff we're doing. And actually I had a version of this where we used one of those models via Ollama, but getting everyone to run on their laptop, like, oh boy, it's just too hard for a short workshop. Yeah.
Use like agent skills, like font skills or.
Haven't, I should. Do you? Okay. I need to learn. I better ask Claude how to use those. Do you have any recommendations?
Still learning it. Bob did release like a skill system.
Oh, cool. I thank you all. I actually have to hightail it out of here. But this was super fun.
Let's try our speaker.
Thank you so much.
Let's not do it.